The next step is planning our top of climb point. We need to calculate where we'll end up when we get to our planned cruising altitude of 5,500 feet. To do that, we will use the Skyhawk POH. Going to section 5, performance, we can find a climb performance chart. Both of these charts can be useful to us, rate of climb and time, fuel, and distance to climb. I want to start by looking at time, fuel, and distance to climb. The way we would use this chart is by taking the altitude that we desire to climb to, in our case 5,500 feet. We have 5,000 and 6,000 pictured here, so we need to interpolate between the two of them. Note temperature, climb speed, rate of climb. They give us time, fuel, and distance. So if we were to interpolate between 5,000 and 6,000, we would find that the time is somewhere between 9 and 12. Rounding that 10.5, we could call it 11 minutes. Now that would be a climb from sea level. So if there are 2 minutes to get from sea level to 1,000 feet, and we're starting at Greenville downtown, which is 1,000 feet above sea level, we would need to subtract 2 minutes. And we could determine that it would take us 11 minus 2, or 9 minutes to get to our climb. Now the climb time numbers will usually be fairly accurate, but the distance numbers will not, unless all conditions are met. For example, the climb speed assumed here is your best rate of climb. For most of our operations at US Aeroflight, we will plan to use the recommended cruise climb of 85 for better visibility, engine cooling, etc. Note also that the fourth note here says distances shown are based on zero wind. We have a decent tailwind on our flight today as we're planning it, and so we will encounter a distance that is different. If you would like to take the time number from here, you can calculate it that way. Another way to get the approximate time to climb would be by using this chart, the rate of climb number. You can see that at sea level, at 0 degrees Celsius, we're getting about 700 feet per minute climb. At 2,000, about 600. At 4,000, about 500. At 6,000, about 400. If you were to average all of these numbers out, you would find that it comes to between 500 and 600 feet per minute. Again, this is at the best rate of climb. So 500 or 600 feet a minute at 2,300 pounds at best rate of climb will probably be about 500 feet per minute when we're doing 85, a slightly shallower angle of climb. Let's assume 500 feet per minute. If we're climbing from Greenville downtown, which is 1,000 feet above sea level, to 5,500 MSL, we're climbing a total of 4,500 feet. Assuming that 500 foot per minute rate of climb is the average, take 4,500 feet, divide by 500 feet per minute, and you come up with 9 minutes to climb, which is the same as our time, fuel, and distance to climb chart said. So that number seems fairly accurate. So here under time, ETE, estimated time en route for this first climb leg, we will put 9 minutes. Now we have our ground speed with that tailwind will be 106 knots, and our time will be 9 minutes. So we can use the other side of our E6B to calculate exactly where, distance-wise, our top of climb point will be. Note the instructions here. Set miles per hour, or knots, under the black triangle. 106 knots, set to the black triangle, would look like that. Now it says distance is read on the outer ring, time on the inner ring. We know our time was 9 minutes, so find 9 minutes on the inner ring read the distance that corresponds on the outer ring, and you'll find that is 16 miles. So here under our leg distance, we will write 16 miles. Now, take your chart and your plotter. Make sure you're on nautical and sectional, and measure 16 miles away from Greenville downtown along our true course line. Right here is 16 miles away, so we will put this mark here to designate our top of climb point.